So what we are doing here, it's with complex numbers, but it's the exact same thing that was on your quiz. Okay? We are going to convert polar numbers to a rectangular number. That's exactly what we did on the quiz. You converted from polar to rectangular and rectangular to polar. That has not changed. The only difference with what we're learning today and what we learned before is complex. Okay, that means it has an I in it. Okay, that means it's going to look like those things eventually. All right, that's the only difference. So we look at this first problem. We're going from polar to rectangular. In the end, we want it to be in rectangular form. Okay, when we say rectangular, what two letters are we looking for? X and Y. I want to figure this out in terms of X and Y. So I need to convert what they gave me into X and Y in order to put it in rectangular form. So which of these four equations over here are going to help me to solve for X and Y? If I want to solve for X, which one solves for X? That one. If I want to solve for Y, which one's going to solve for Y? That one. Those are the two formulas I'm using. X equals R cosine theta. And I'm going to do Y equals R sine theta. Those are the two formulas I want. I'm trying to get to rectangular form. So just like we did yesterday on the quiz, hey, you're trying to get rectangular? Use the X and the Y formula. Okay, now all I got to do is figure out what's my R and what's my theta. Okay, so this is what's given to you. That is a polar complex number. A little bit, yeah, and we'll get to that. First, let's look at R. What's my R going to be? Where's my R located? In front of the, whatever's in front of your parentheses, oh, that's your R. So what's my R for this problem? 2. So where I have R, I'm going to plug in the number 2. And my theta, what's my theta going to be? 30. Cosine of 30. It's the only angle in the problem, 30 degrees. So 2 times sine of 30, 2 times cosine of 30. Once we've gotten to that, it's exactly like what we did yesterday, what we did on our quiz, and what we've done for the last 2 weeks. We're converting 2 times cosine of 30. Sam, what do we do to find cosine of 30? Look at our unit circle, and I'm looking for the x. So we go to the unit circle at 30 degrees, look up the x, it's radical 3 over 2. Can you reduce that, Sam? What can I do? Cancel out the 2. So my answer for my x value, it's radical 3. Okay, we took 2 times whatever cosine of 30 was, which was radical 3 over 2. And we can do the same thing with our y's. It's going to be 2 times sine of 30. So I go to 30 degrees. I look up my y value. It's 1/2. Can I reduce that? What's half of 2? Half of 2 is 1. The 2's cancel again. My y value is 1. Cool, I'm not done yet. I'm almost there. I need to convert this to rectangular complex, which means I need it to be in that form right there. Okay, so in the end, you want to say z equals. They use z to represent, hey, this is fancy complex numbers. Okay, so z is equal to x, so radical 3 plus I times y. Okay, so we're going to take I times y here. So my y value is 1. So 1i, or just I. You can put 1i. I'm going to just put I because 1 times I is I. That's it. Does it make sense what we did? Not very tough. It's a very similar